about 30% of AI projects in healthcare have moved from a pilot or proof of concept phase into full production. This is highlighting the scale challenge that infrastructure platforms aim to solve. My name is Paul Nashawaty. I'm a principal analyst for the practice aptitude research, and I'm joined by Lars from Corti. Lars, how you doing?
Hi, how are you?
I'm doing well. Great to have you on. Why don't you introduce yourself and Corti to the audience?
Yeah, so my name is Lars Maaløe. I have a background within machine learning research, researched in deep generative models before it became like Gen AI and everybody knew about it. And I'm the co-founder of Corti. Before that, I worked on a lot of different technical problems within big tech, within finance, etc. Before falling in love with healthcare and building technology for healthcare, because I think it really matters, and that's what Corti is all about.
Yeah, well, I'm really excited to have you on. I mean, obviously, healthcare is a big topic in the world, right? And having AI impacts to healthcare really does matter. So when we see healthcare AI, it really is an inflection point, Lars. And when we look at it, we see billions have been invested in innovation and has accelerated not only small percentage of AI agents, but actually has really made it into production. This is largely due to trust, governance, and regulatory boundaries and barriers, right? We see that a lot. But today we're seeing that, exploring what it takes to move from experimental to safe, scalable deployments and governed agents really is the focus of where the market's going. So having an agent-driven infrastructure really could be the turning point for AI as a promising tool to really help deliver a reliable digital labor across clinical and administrative workflows. Which, by the way, I can't wait for it to happen because I can't stand going to a doctor's office and having to rewrite something like on 5 different pieces of paper. That's really painful. So, Lars, let's jump right into it. I mean, so first off, let's talk about Corti because, I know our briefing that we had, there was a lot going on there talking about deterministic orchestration without slowing down workflows. Why don't you give a little bit of background of how Corti validates the AI action against these clinical rules and permissions?
Yeah, I think first and foremost, if I knew going into healthcare how difficult healthcare really is, then I would never have done it. So there are so many fields that are more easy than healthcare. Healthcare is its own language, so to speak here. So when you look at the terminology within healthcare, you are easily adding a terminology of approximately 1 million new words that are really, really complex for medications, for treatments, for diagnosis, and so forth. Then you have really, really difficult categorization systems like the ICD-10 systems, ICD-11 system, and so on, with 70,000 plus codes to append to healthcare nodes, etc. And then you have a lot of clinical guidelines with a lot of new knowledge that's pumped into healthcare at all times, which is fortunate for us as patients and so forth. So you have this wonderful complexity with a lot of data, with a lot of very, very specific data for a specific industry. And how we think about that is that we need to build AI systems that can really understand all of that data at scale. And that AI needs to be able to rely on the guideline data, all of the clinical data available, written by human beings, validated by human beings, trusted by human beings, and so on. And it cannot rely on the LLMs themselves, even though LLMs are capable of writing your essay for your kids' homework assignment and all of that at a very high level. They are failing when they come to these very specific, expert-driven healthcare kind of examples where doctors have been training for years and years and years, and new knowledge is pumped in all the time. And that's where Corti really excels, because we are able to apply the AI there, build really, really strong large language models, build really strong speech recognition models, and harvest on all of the clinical data at once.
Well, I'm looking at it from an app dev perspective, and like when I look at it, and I know the world's changing. I know that things are happening very quick. In a regulated environment, it's very different, right? And when we look at Corti's deterministic orchestration layer, it is part of the success of basically validating agents across actions in sub-millisecond timeframes, really without introducing clinical workflow latency. I think that's a big part of this, because like when you look at heritage systems, that's slowed down a lot of the decision-making process. So can you explain a little bit about why this is important, and in particular in high volume environments like nurse triage or revenue cycle operations? Because it really does impact those environments differently than it does in non-compliance environments.
Yeah, good point. So And basically, it's probably good to start somewhere else. Just quickly here and say, how do you get started with Corti? You get started with Corti if you're a developer that wants to get started building an application for healthcare. That could be a nurse triaging application, as you're alluding to, or it could be an agent scribe for doctors, or it could be a clinician to clinician interface, or it could be a voice agent. Then you go into Corti's website, and then you are initiating some agents. We have pre-built a lot of agents. You can build your own agent. You can come with your own experts under that and so on. I'm not going to bore you too much on that. And then you get the code that you can plug into your own application interface, and then you're up and running. We just had a developer that got up and running with a very, very complex application that we just hosted on our website within 2 days, and that can do everything from getting clinical guidelines and whatnot. What is happening underneath the hood, basically back to what you're asking about, is that every time we set up an agent, we make sure that we have the right guardrails around the agentic system. It's a multi-agent system that can tap into a lot of clinical data, guideline data. You as a developer can yourself define what clinical guideline data it has access to and so on. And then you make sure that your agentic system through that is only harvesting from that data deterministically, such that you're not suddenly risking a lot of hallucinations from your large language models. That can be done really, really fast within our system. So we have built memory components to retrieve this data extremely fast, and faster database accesses and so on. So you can get it within like a few milliseconds, really, really like strong agentic requests. And you can also have reasoning cases where you're reasoning for a longer time, similar to what you're used to from the OpenAI and the Anthropics, but just for the healthcare case.
Yeah, that makes a lot of sense. I think when we think about it in the context of modern systems, it's about access and latency, but it's also about safety too of the data, right? And the framework that basically provides blocks to small errors so they can be before they're propagated across, the EHR kind of billing or referral systems. This is also a factor that kind of plays into the actions that are controlled, traceable, and auditable to prevent cascading failures. That's a big factor as well as the latency, as we talked about. But what are the mechanics? And when we think about it from an agentic framework, what are the mechanics within the agentic framework that prevent safety spirals across, interconnected systems? And how are these edge cases, or you mentioned hallucinations and model hallucinations, interpreted? How is this intercepted before the downstream propagation?
Yeah. You're totally right. So if an error is happening in a long workflow, right, and if it's an agentic workflow, then those errors compound, right? Then you're going in the wrong direction, and that can have an exponential impact on the errors that are compounded into the system here. And how we're ensuring that is happening and not happening is that we have a lot of checks and balances that are AI driven inside the system. We, for instance, have this system that we introduced earlier last year that is called recursive facts extraction. So we have this ability to retrieve facts, and then we're actually able to put them into a graph setup such that we can ensure that we have validated those facts against the ground truth, so the actual input data. And thereby we can ensure that the system is never hallucinating a new node inside this graph structure. That system is guardrailing us quite heavily in terms of knowing exactly where we are in terms of the groundedness of the data and what we are able to do from that groundedness of the data. Because the worst thing that is happening with LLMs is that when they're starting to think of new things, or say, if this happened, then I'm used to this also happening, even though that was actually not happening in the case. And that's what we're alleviating with doing a lot of checks and balances that are automatically happening in the belly of the beast of the agentic system.
Yeah, I like that response. That kind of ties into where I was going with the next part of it. In my practice, I often deal with past, present, and future, right? And when we think about healthcare in general, there's a long life cycle of the heritage applications that are within healthcare. But now we have this kind of new concept that it's not so new anymore, I guess. But MCPs and A2A interoperability, right? This is where the open ecosystem allows standards for multiple agents and systems to work together while autonomously, working within governance controls. But this is preventing, rogue automation in complex multi-vendor healthcare environments. This is the thing that we're hearing across the board. Using agents and using, the technology in order to kind of access these heritage systems, once the data is extracted from the heritage systems, it causes this concern of, is it in compliance, regulation, and governance? And I would imagine, and more so, this will be the case in healthcare. So when we think of MCP and agent-to-agent standards and how enables interoperabilities while preserving governance and in the systems. What does this mean from the implications for multi-vendor healthcare AI ecosystems? Because it really is a factor for developers.
Yeah, so we're true believers that if we want to be a serious contender in the AI space for healthcare, then we need to build in the open standards first and foremost. So, and that also means that if someone is better than us at some point, then you can rip us out and then you replace us, so to speak. And then we will continuously aim at being the best at what we do here. And that also means that you can expand us. So if someone else is coming with an A2A applicable protocol agent, then they can plug it into our framework. They can bring their own sub agents into our framework. They can even plug our framework into the already existing framework. And then suddenly you're working from a modularized system where I think that healthcare has been really, really burned from the history of being locked into the big electronic health record vendors, and they have their data. It's difficult to get out of that. When you're first choosing your system, you never choose a new system, that kind of mentality. Without naming any names, I think that the AI systems that are implemented inside healthcare needs to be open, and every customer needs to require that in order for them to make sure that they can change the systems according to progress.
Yeah, I hear you, but I also know that our research is showing only 11% of agents actually reach production, right? And that, to me, there's a lot of investments. I feel like in 2025, that was a year of innovation, and in 2026, it's the year of implementation. So we see that most AI agents are basically failing to reach production, and this is largely due to trust, compliance, and auditability, the gaps. And, addressing these challenges and having control over a full traceability, as well as having, making AI safe enough for regulatory environments is a key factor. So given that only 11% of agents reach production in 2025, what structural barriers, like technical, regulatory, organizational, what does Corti do to kind of help with infrastructure that directly addresses this? And what is the reposition of AI from a software tool to basically a hireable labor in the healthcare budgets, right? Because we're seeing that agents are actually, virtual agents are actually almost being moved to an FTE cost. So what are your thoughts there?
Yeah, I think let me try to unpack it a little bit here, right? Because I think that to be quite frank and direct here, if I was a healthcare provider system, I would never trust any agentic system that is not ours right now for a multitude of reasons. A lot of these agentic systems are really, really poor at choosing different agents. So, and you never have a full traceability and deterministic behavior in terms of which agent was called. The other thing is that the fact that you cannot get full traceability is harmful, right? Imagine that you have made an agentic patient or made an application for a patient case, and you want to find out what actually went wrong in the recommendation or the questions asked and all of that, and that you're actually not able to trace that well enough. That's problematic, right? Even worse, a lot of these agentic systems have not very well solved these the memory component, making sure that I know that the large language models they're claiming that they have this very broad context, but if you try to actually challenge them with a big patient file, then you learn that the context is bogus, and they cannot retrieve the right data from that context. Hence, their in-context memory is not very strong. So a system needs that memory to make sure that you have a full context of the situation and a full overview. And then finally, I think that there are a lot of like software engineering things that we have done in our agentic framework where you can pass strict types between and so on, such that you're not polluting the unstructured data with patient-centric PHI, etc. data inside that. So I think that to your point, 2025 has been very much in the building phase, but 2026 is when you see companies like ours really being aggressively serious about real agentic frameworks that can actually scale and can actually safely be put into production.
Yeah, without a doubt. I mean, it also not just from a technology perspective, but it also unlocks this $265 billion administrative opportunity that's out there, right? We see that there's a huge market combining AI reasoning with strict validation really helps with that automation. And this automation ties back to billing, coding, and prior authorization workflows. And that is really what's turning AI from advisory into operational labor savings. But like we see this, I mean, we're not the only ones that are seeing this. McKinsey estimates the same thing, with $265 billion in administrative savings, it's really tied to that billing and prior authorization space, right? So how does Corti really help with governing the execution models, unlocking the value, and compared to the traditional RPA or ambient AI solutions?
Yeah, wonderful question. I wish I could give you like a short answer, but we have 1,000+ developers building different applications on our platform. So if I were to like give you all of the answers, then I would sit here for a long time. But I could give you some pocket of answers, right? So if you look at the healthcare system as like there's the intake functions, like everything that is like when from a patient calling into the hospital, being triaged when they get into the hospital, and so on. All of those things, a lot of that is getting automated right now, in terms of voice agents, in terms of agents that have conversations with the patients before they go in, finding out what is wrong, asking more questions. Remember, the patient have much more time when something is wrong with them or their loved ones than the healthcare system themselves, right? So you want an agent that can ask a lot of questions, that get as much data on the patient before they actually meet a human being. A lot of those cases we're covering, a lot of clinician to clinician conversations. I don't know when you were last in a hospital or an inpatient hospital, but the phone keeps on ringing for these clinicians out there, and scaling that clinician conversation to what we do as a tech company. We have async communication because it scales, right? I can sit in this call and I can make sure that people can communicate to me while I sit in this call, and that scales, right? Then I have a lot of work to do afterwards. Then we have reimbursement, revenue cycle management. We have a lot of cases in terms of that, all the way to the payers. We're also on the payer side with our technology and supporting a lot of everything from health insurance to so on cases where our AI is going through the cases and coding and so on.
Yeah, but healthcare AI is shifting from simple interface and validation execution, requiring really new infrastructure, right? It really is, because it's shifting, right? Even though we know that the heritage environments exist, we know that it's going to take a bit for it to change, but governance and control autonomy is becoming a key competitive differentiator in the market. I mean, I know that healthcare is not, I don't know, not viewed as like a competitive space, but like it's a necessary space to have operational efficiencies. And we're seeing this in the tech sector, right? We see that, NVIDIA-backed governed agent execution emerges as the new GPU workload category. This is, how might this shift competitive dynamics amongst healthcare AI platforms? EHR vendors and hyperscalers invested heavily in agent-based, automation, because this is a big factor. What I always was seeing in 2025 and saying was human in the loop, every stage. Right now, we're kind of saying, okay, we're building confidence. We're understanding how things are working. We're not requiring the human to check things, because honestly, we can't slow down, right? Because if things have to pick up, and we have to have those what we would have a human in the loop doing, those humans doing other things. What are your thoughts there?
Yeah, I think but also just to extend your point here a little bit here, right? That there are also all of the cases that we would wish that someone would do that we don't have time to do, right? So I think that the clinical documentation integrity, we have been talking about it for so many years, but the investment in terms of it is limited if it's not about revenue cycle management in the US especially. And I think that imagine that you can now have an agentic system that can do CDI at scale, right? In order for the betterment of the patient, for the betterment of the system, and so on, right? So I think that when you start to open up the box in terms of how many things that you can analyze in the everyday, like everything from bedside allocation or bed allocation to also, we have a lot about medication reconciliation right now at the moment, just going through the medication list and see if there is some new research out there that could actually show something that someone should be made aware of, and all of that. So I think that the market and the competitive landscape in terms of this is changing rapidly, and I think that also the very closed platforms are forced to open up right now, because they need AI to crunch their data and seek insights in the day-to-day operations to optimize.
Well, Lars, we talked about a lot here. What do you recommend to the audience? Where can they go to learn more?
I think basically our website. You can sign up, you can get started, you can build your own applications. We also have more and more clinicians that are now building their applications on vibe coding platforms, and they can do that by just plugging in our API, and then they can build their own application and then go to the Monday meeting and show their colleagues how cool this would be in their workflow, and then start to spark some interest. So we have a lot of builders out there, and we have more and more every single day. So get started building and build your idea.
Great. Well, Lars, Thank you very much. I really appreciate you being on the podcast today. Thank you for being my guest. And also a big thanks to all of you who've tuned in. We really do appreciate you being part of the AppDevANGLE community. But for now, that wraps up this episode. But we'll be back next Wednesday with another conversation diving into the tools, trends, and talents shaping the future of application development. So whether you're deploying at the edge, building with AI, or modernizing your cloud stack, we've got you covered. So be sure to follow us on social if you have any thoughts, questions, or just want to connect. Until next time, stay curious and stay building.